Okay, a very good afternoon, everyone, and welcome to the chemistry class. I guess I'm able to see the students from the Shillong Center. First of all, can you please raise your hands? The students from the Shillong Center. Are you able to see me? Just raise your hands. Okay, very nice. Okay. So, first of all, let me give you my introduction. As you have already seen the name there. So, I have done the BTech from NIT Jalandhar, and it's been around 4 years of teaching experience. And earlier, I've taught in the resonance in the quota. Okay. So, I will be taking the chemistry classes. And just tell me one more thing. How many of you were there in the 12th class of the Avanti? When we were having the 12th class, because today is the demo class, right? So many of the students were also there, those who haven't attended any coaching. How many of you have attended the coaching in your 11th and 12th? You can just raise your hand. I'm very much able to see your faces here. Do you people have attended any coaching earlier? Shillong Center. If yes, then raise your hand. If no, then it's okay. And you can just type. I'm able to see the comments here. So I guess there is the desktop over there with the keyboard. So you can just type it down there, and then I will be able to. And see, this is the process, how we used to take the classes. And this is the good thing with the Shillong, that they do have the camera over there. At some of the centers, the camera doesn't even, we don't have the cameras. So we have the only one connection, this beautiful keyboard which you have over there and the screen here with me. Okay. So I was just asking that how many of you were there in the 12th class of the Avanti? So I guess nobody is raising the hand, so all of you are the new faces are there. Is that so? Okay, you can just write here. Okay, nice. Okay, so this is the another good thing of the dropper batch, that you people have already given your board exams. So now, like for the one next year, you have the total focus on your competition exam, okay? And see, this is actually, it's very difficult that, you will be getting the good marks in your board exams also, and at the same time, you are cracking any competition exam also. Okay, so don't worry. Many of the students have the drop, and just with this complete 1 year, I'm just saying that if you put the total hard work in this particular 1 year, you will be definitely getting the very good marks in your exams, and you will be getting admitted into the colleges. Okay. Okay, tell me one thing more, Shillong, that how many students are there from the NEET background, and how many are for the JEE? That how many students will give the NEET and how many will give the JEE? You can just write it down here, okay? I guess total I'm able to see 1, 2, 3, 4, 5, 6 students are there. Okay, so you all are for the NEET, right? Okay, just raise your hands. Now the screen is all are for the NEET, right? That is okay. So I am able to see all of the future doctors here. So all of are the future doctors, right? That is so nice. And if I just tell you, have you given the NEET this year? Like on the 5th May, there was the NEET exam, na? How many of you have given the NEET exam this year? Raise your hands. Okay, some are raising their hands. Okay, so how was it? How do you find the chemistry there in the NEET? You find it easy? Tough. Obviously, I'm the chemistry teacher, so I will be more talking about the chemistry. How was the chemistry? Okay, just how many of you are saying that we have find the chemistry easy? Raise your hands. Girls are there, I guess. Actually, my screen is quite far away, so I'm not able to see the complete faces of yours. Nobody is raising the hand. So you find the chemistry difficult? Moderate with the question mark. Okay. So you find it moderate. Okay, just I will tell you. See what happened this year, and this is the general trend for the chemistry. If you just look at the questions were not that tough, and this is the overall, the we can say that the pattern of the NEET exam. If you just look at the questions, the level is, you can say that yes, it was the moderate kind, with some of the easy questions were there and some of the tough questions were also there, okay? But if I talk about that, most of the questions were of the moderate level. If you have studied the NCERT very well, or if you have studied, the basic concepts very well, then definitely you will be getting the very good marks in the chemistry, okay? And one more thing which is very important is that, this I usually say for the ITJ mains also, and this is for the NEET also, that without chemistry, it is very difficult to have the good rank, okay? I'm not saying this because this is my subject, so please students read that subject, definitely not. You can ask your seniors, you can ask your, relatives also, or those who got admitted into the colleges, then, they will also describe this thing, that chemistry, actually it's very important to score good marks in the chemistry, okay? So, your rank deciding factor is the chemistry. So, okay, then we will start with the organic. As you all know that we have the 3 topics in the chemistry, 3 type of chemistry is there. One is the physical chemistry, other is the organic chemistry, and one is the inorganic chemistry. You all know already, okay? Now tell me one more thing, Shillong. How many of you like chemistry? This is very important, na? How many of you like chemistry? Or no, ma'am, we don't like it. It's kind of so many things to remember, so many reactions are there. How many of you like chemistry? Just raise your hands. And I would be happy if you give me the honest opinion, One student like chemistry. I guess that is on the last test. What about others? Okay, if we don't like chemistry, then why we don't like chemistry? Tell me, no? And any of the student can go at the back and just write your answers there on the keyboard. Just feel free to write anything. Just feel free to ask your queries. So you see, this is how, we will be, communicating with each other. And it's very important. It's very important for you people to be interactive. And, that is how it, then only I will get to know that how to, run the class, that students are getting it or not. And this is for everyone. And this is the very first class, so I'm just making it very clear. Whenever we will be reading, and this is not only for the chemistry, whenever you are reading any kind of topic or any, particular concept is going on in the class, if you are not getting it, you can simply either raise your hand, or either you can just write it down that, ma'am, please explain it again, we are not getting it, or, we are having some kind of confusion. Any type of queries there, you feel free to just write, okay? And this is for all of the students there, okay? So, we will be starting with the organic chemistry. Okay, you can just tell me how many of you like organic? Which part of chemistry you like more? Physical? Okay, the one student, okay, some of the students like organic. And yes, I like, and this is the also very general opinion which I used to hear from the students. What they used to say, that ma'am, in the organic we have a lot of reactions. So how we can, recall all of the reactions? For organic chemistry, it is very, very important to follow a sequence, If you randomly choose the reaction from in between, you will be all of the things will get messed up. And then obviously it will be very difficult to remember the reactions. So very important thing is that proper revision with the proper sequence, okay? That you are continuously revising the reactions and then following a particular pattern, okay? So don't worry, we will be reading everything. So let's start with the organic chemistry today. And today we will not be actually starting the reactions. The most important thing is, like you already know, that there are certain topics here, like IUPAC nomenclature is there, isomerism is there, reaction is there, Grignard reagent is there, so many things are there, right? But the most and the very important thing is the general organic chemistry. if a student get the journal organic chemistry in a very good way, I am sure that he or she will get a very good command on the whole of the organic chemistry. If you just do this particular topic in a very good way, then no need to cram any reaction, no need to just means without any there will be the logics there which you can apply with the help of journal organic chemistry. Okay, I'm just writing few topics here. All of you understand that we have a reactant. Okay, I'm just talking about the journal things right now. Okay, so we know that whenever there is a reaction, the reactant is converting into the products, right? Reactant is converting into the products. Now you have heard about the term which is known as the mechanism. Okay, how many of you know what is a mechanism? Raise your hands along. You have heard about this term, right? How many of you know about the mechanism? When I say that this is the mechanism of a reaction. Okay. What about others? See, what happened in this case, like you can just take a very simple example. All of you are sitting over there, 6 students are there. All of you are reactants, right? So you people are reactants, your reaction is going on, okay? And you will be converting into a product, okay? When will you convert into the product? When after this 1 year you will be getting the good marks and the good ranks, you are converted into the product, okay? Now, what is the mechanism here? This complete 1 year, okay, like the journey of the reactant towards the product is known as the mechanism, okay? So you have a complete 1 year to, prepare yourself for your respective exams. So that particular 1 year will be your mechanism, okay? Or mechanism is basically the journey. You are sitting in your class, you come to the center. There will be so many routes from your home to the center. There will be different roads. You can take any of the road, okay? So I'm saying that there are several different methods to reach one particular center. So there can be various mechanisms to reach one particular product, right? And there is one more term which is known as catalyst. In some of the reaction we use catalyst. How many of you have heard this term catalyst? Raise your hands. You know about the catalyst, right? All of you know. Very nice. So if when I ask you this question that what is the catalyst, you will say, ma'am, the catalyst is any compound which changes the speed of the reaction. Or you can say that generally it increases the speed of the reaction, okay? So this is the case. Like in many of the reactant, we just put the catalyst perform its work, convert into the product. But please make sure that catalyst do not or we can say that catalyst is not present in the product, okay? So catalyst just go, take part in the reaction, increases or decreases the speed and then comes out. That is only the work, okay? So these are the journal terms which I have just described. Now one more very important thing. Now there are 2 ways for the bond breakage, okay? So I am writing that bond breakage is of 2 types. How many of you know this thing? Raise your hands. Or you have heard about the term homolytic fission or heterolytic fission. Fission or cleavage sometimes we use. Have you heard? How many of you have heard about these terms? Raise your hands. One is the homolytic fission, okay, that is nice. Other is the heterolytic fission. We are just today discussing the, the important concepts which we will going to, study when we will study one particular mechanism or any of the reactions. So please keep on writing it. Now, if I am saying that we are doing a homolytic fission, everyone just look at the screen. See, I am just taking an example. Let's say we have a AB bond, okay? You know that a bond is formed with the 2 electrons. So 2 electrons will be there, okay. And when you are homolytic, you are doing the homolytic fission, see what happened in this case, both of the atoms will take one electron. Just look at the screen. See, this one electron will be taken by A, this one electron will be taken by B, okay. So what I will be getting? Do you think what I will be getting? I will be getting a radical and a B radical. You have studied the radicals, right? You know what is a carbon-free radical. So whenever we have a one single electron on the carbon, we call it as carbon-free radical, okay? So this is HOMO. HOMO means both of the atoms are getting one electron. Now look at here. If I am doing the heterolytic fission, what will happen? Heterolytic means that one atom will take both of the electrons. Look at the screen. Like these are the 2 electrons. B will be taking both of the electrons. So what charge will be there on A? Shillong, tell me. If B is taking both of the electrons, what charge will be there on A? Plus or minus? No, why it should be neutral? How many of you are saying plus? Tell me. If you are breaking the bond and B is taking both of the electron, exactly, plus charge will be there, right? So A plus will be there and B minus will be there. And always remember this thing in the chemistry. What? That, whatever atom is taking the electron, it will have a negative charge. And you can just, relate it like this. That good people, they are very good people, they always used to give the things, so they always have the positive charge. Bad people, negative people, they always used to take the things, they always used to gain the things, okay, so they will have the negative charge. This is the way you can relate. So I hope now the homolytic fission and heterolytic fission is clear. Any doubt, anyone? If anybody having any doubt, just raise your hands. No doubt? Okay then, okay. So we are clear with the homolytic and heterolytic fission, okay. And today we will going to study the electron displacement method. These are the topics which you have studied in your 11th class, okay. So electron displacement methods. Now what are these? These are of 2 types actually. One is the permanent, other is the temporary. One is the permanent effect, we call it as the effects, okay. So we are just going to study, you have heard about the inductive effect, the resonance and the hyperconjugation. How many of you have heard these terms? Raise your hand. Inductive effect, resonance and hyperconjugation. All of you have heard. That is so nice. So permanent effect and temporary effect, okay. So the names which I have just called, all will come under the category of the permanent effect. So we have inductive effect in this category. We have resonance here. We have hyperconjugation. We will study one by one, okay? And in the NEET exam also, direct questions are there from the GOC, okay? So it's very important to do the GOC in a good way. I will be telling you the previous year questions also, okay? When we will do one topic, we will do some, the questions also. Then we will discuss the previous year questions also. So all of actually these 3 effects are important for us, okay? But we will study, and there is one more, just write down the name, nobody will ask you about that. Actually, it's not there in much detail in our syllabus. That is an electromeric effect. This comes under the category of temporary, okay? But these three are important. So we will do these three in a very good way. Okay. So let's start with the inductive effect. Let's understand first of all what is the inductive effect, and then we'll write, okay? And you know, we will not be writing a lot of theory, okay? No need for that, I guess. Obviously, we will write that much part that will be understood by you, okay? So I'm just saying because we are not much focused about your board exams now. So I guess there is no much requirement for writing the theory. Or if you want to write anything much in detail, just let me know, okay? Then I will write everything here and then you can write, okay? So what is the inductive effect? Now look at the screen. You all of are aware with the structure which I have drawn on the screen. This is what? This is HCl, okay? Now tell me which kind of bond is this one? Or you can tell me which is the more electronegative atom here? Chlorine or hydrogen? Which is the more electronegative atom? I hope all of you know that. Chlorine is the more electronegative atom. Yes. See, this is, first of all, this is a covalent bond. Okay, I'm not saying HCl is an ionic bond. Why? Because you know that HCl, dissociate into H plus and Cl minus only when you put it into the water. Okay. So HCl will be having the ionic bond when you are putting it into the water, okay? Then it will dissociate into the ions. But if I am simply writing that I have the HCl, that particular bond is the covalent bond, right? Now, I know that more electronegative atom is Cl. So it's the more electronegative atom. So what will the more electronegative atom do? These bond electrons will be attracted by the chlorine towards itself. Or I can say that more electronegative atom will pull the electron density towards itself. So which charge will be developed over the chlorine? Can I write it as delta minus? It's a partial charge will be developed over the chlorine. And what charge will be there over the hydrogen? It will be delta plus, okay? So what can I say about this bond? Do you understand a polar and non-polar? When we are getting the partial charges in a compound, that particular bond is known as a polar bond, okay? Are you getting it? Okay. When we have the electron negativity difference, one will pull the electron towards itself, so it will be developing partial negative charge, the other will have the partial positive charge, which causes the bonds to be polar, okay? So now, whenever we have this kind of polar bond in the chain of carbon, okay, and then the effect which is producing is known as the inductive effect. Again, look at the screen. See, now I know that I have a carbon and a chlorine. Which is the more electronegative atom? We have a carbon, we have a chlorine. Which is the more electronegative atom? Again, chlorine is the more electronegative. So what will the chlorine do? It will pull the electron density towards itself. It will have a partial minus charge. Here this carbon will have partial positive charge. And this carbon will have delta plus charge. It means the charge is diminishing as I am going away to the chlorine. And this will have delta plus. If I just go away more, then the charge will diminish completely. Okay. Now this effect, this type of delta charges development is known as inductive effect. Anybody having any doubt? Raise your hand or write it down, then we'll write one definition here and then we'll do questions. Is it clear, Shillong? Okay. Okay, so you know what we can write? We can write it as the partial charge displacement or development, you can write, due to the electron negativity difference in the carbon chain is called as inductive effect. Right? Okay, so I hope everybody has written it. So how many types of inductive effect is there, Shillong? How many of you know the answer? Raise your hands. How many types of inductive effect is there? Tell me, I know you are so intelligent students. Two types of effect is there, right? What is the name actually? See, if I can write the types here, you know, the types of inductive effect. I'm writing in the short form, IE, okay? So this is inductive effect. So, you know, you can also write it like this. One is the plus I effect, other is the minus I effect. Yes. One is the plus I effect, other is the minus I. Very simple it is, no need to have any confusion. Let us understand with the help of an example, okay? See, I am writing an example here. Let's say if I am writing here now the example with silicon, okay? And here I have taken an example of again a chlorine, okay? Now you people will tell me, what charge will be there on the silicon? Are you able to see the difference here? Okay, just tell me, which is the more electronegative atom here, carbon or silicon? Silicon is from the member of the carbon family, we all know that. You know na, this thing, look at the screen. I'm writing here, carbon, silicon, germanium, SN, Pb. Okay, this is the carbon family member. So down the group, what happened? Electron negativity decreases. We know this thing, okay? When we go down the group, in a periodic table, when you go down the group, electron negativity decreases. So silicon is less electronegative. So now we can say that carbon is more electronegative. So what will happen? This time carbon will take the electrons towards itself, okay? More electronegative atom will take the electrons towards itself. So now it will develop the delta minus charge and it will develop the delta plus charge. And it will have delta, delta minus, delta, delta, delta minus, okay? Is it clear to everyone? Any doubt? Raise your hands. You understand the carbon silicon, why the charge displacement is like this, and this is we already done. Okay, so this time chlorine is taking delta minus, delta plus, delta delta plus, delta delta plus. Okay. So you know you can just keep this thing in the mind that the groups, whenever in a carbon chain a group is like that, it will be taking the electron towards itself, okay, like chlorine. Chlorine is taking towards itself. I have already given you the example. Negative people, bad people, you know, they always gain the things from the other. They always take the things from the other. So just give them as the negative, okay. So those groups will be coming under the category of minus sign. Those groups which are the positive one, okay, those who are the good people, those who always give the things to the others, those come under the category of plus I, okay. So plus I will give the electrons, minus I will take the electrons, right? Or can I say one more thing here, that we can call them as electron, what we can call them? We can call them as electron releasing groups. And I can call them here as electron withdrawing groups. Okay? I'm not writing the definitions here, okay? I hope you are good with the examples. So I hope the electron releasing group and electron withdrawing group is understood by everyone there. Okay, now I'm giving you a question. I will be writing certain compounds with the different groups, okay? You people will tell me which is the plus I and the minus I, okay? So let's write. Identify the plus I and the minus I groups. You will be telling me that which groups are the plus I groups and which group will be the minus I groups. In the first question, I have written an example of fluorine. In the next question, I have written the nitro. Let's say this time I'm drawing a kind of, let's draw some other structure. I'm drawing a cyclic structure here, okay? I've drawn a cyclic structure. Now I'm putting a chlorine here. I'm writing one more question here, okay? Let's take an example of CH3CH2Li. Number 5 CH3CH2 MgBr. This time I'm drawing a bond line structure. Try these questions, quickly tell me the answers, then we'll discuss. So you are done with the questions? Those who are done, raise your hands. Okay. Then write the answers here along. 1, 2, 3, 4, 5 and 6. Which are plus I, minus I. Okay, for the first question. How many of you are saying as the minus I? for the first question? Okay, all of you are saying that is the minus I. So nice, because we know that fluorine is the more electronegative. Definitely it is the minus I. Okay, so it will take the electron towards itself. I'm just drawing an arrow here. Okay, like towards the fluorine. So you can also draw. What about the second one? How many of you are with the minus I for the second one? Okay, many of you are there with the minus I. That is nice, because again we know that nitro, always remember nitro is a very good electron withdrawing group. Okay, carbon and a nitrogen is there. Nitrogen is more electronegative, so it will again take the electrons towards itself. It's a minus I. The third one is again, I hope you all know this is a minus I. So chlorine will take, and you can draw the arrows like this one. Okay, so you can just draw the arrows like this. Okay, so chlorine is basically taking. Now tell me the answer for 4 number. What will be the answer? How many of you are saying minus I? Nobody is saying minus I. Then everybody is saying plus I. How many of you are saying plus I? Or ma'am, we are saying nothing. Okay, so everybody is saying plus I, good, because you know that lithium is a metal. Lithium is an electropositive thing. And you know, always remember this thing, whenever a carbon is attached with the metal, metal always have the positive charge over itself. Metals always do the oxidation, they always give the electrons, okay? So metals cannot have the negative charge, okay? So carbon will be having the negative charge this time, so it will be like taking this way, okay? So it is a plus I group. Now what with this? How many of you know the name for the 5th number? You have seen this, right? You have studied the reactions of 5th number compound. How many of you know? Okay. It is what? It is the Grignard, right? It's a Grignard reagent. Again a magnesium is there, so that means the carbon will again take the electrons towards itself. So it is again a plus I group. Okay, so magnesium is again a plus I group. Now tell me the 6th number. You will tell me that which functional group is this one? In the 6th number, which is the functional group, and then what will be the effect? Just write the answer along. How many of you know that which functional group is the 6th one, 6th number, the last question? What is the functional group there in the last question? It's the aldehyde, right? It is the aldehyde. CHO is there. I've just drawn in the bond line form. And which group is this one? Everyone just remember. Carbonyl. This is what? This is known as a carbonyl, okay? When C double bond O bond is there, this is a carbonyl. And carbonyl always take the electrons towards itself. The reason is, you know that this carbon is sp2 hybridized, okay? I hope the hybridization is clear to everyone. If still doubt, you can ask me, okay? So I'm saying the sp2 carbon is an electronegative carbon. So it will take the electrons towards itself. So it is again a minus I group. And just remember one more thing, very important everyone. When carbonyl is attached with the hydrogen, this is what? This is an aldehyde, okay? Like you were writing al is the IUPAC name, this is aldehyde. When we have both side carbon, what is this? How many of you know the name of this one? Raise your hands. Those who know that which functional group is this one? Okay, this is what? This is ketone. I have just drawn the structure of acetone here, okay? So this is ketone. What about this? When you have a OH, this should be known to everyone. Raise your hands, how many of you know this last one? Here. It's the carboxylic acid, right? So it is the carboxylic acid. Okay, so this is carboxylic acid. And what about this one? We are just revising it, okay? What about this one? If I have here NH2. Any idea? The last one. Carbonyl is there, C double bond O NH2. We are discussing, but we don't have the idea. We have the idea. Yes, girls? Give me the answer. Is it an amine? Okay, how many of you are saying this is an amine? Raise your hands. Okay. So this is, yes, this is amide, not amine, Shillong. Amine is this, only NH2, okay. So when you have only NH2, this is amine. This is what? This is amide, okay. When you have C double bond O and then NH2 is there, this is amide. And your favorite one more. What about this one? R, you understand now? When I'm writing R, it means any alkyl group is there. Okay, so what about this one? This one. How many of you have the idea? You people have studied the reaction of this compound. You have prepared this compound. How many of you have the idea? Raise your hands for this compound. Okay, so girls have the idea, right? This is what? This is ester. You have done the preparation of esters, na? Esters having the fruity smell. You know that? So these are the functional groups, okay? So I was just telling you that, whenever you see any carbonyl, like aldehyde, ketone, carboxylic acid, amide, ester, all have the carbonyl group. So all of these group will come under the category of minus I, okay? All will take the electron towards itself. So these all are minus I groups. These all are minus I group. This is also a minus I group, okay? So you can just keep this thing in your mind that whenever you see a carbonyl, okay, Shillong, I know that the one who is sitting with the computer is a boy, and I guess the rest of the are the girls, those who are sitting on the different side. I know that. I was just asking the girls, okay? Actually, my screen is quite far away today in this classroom, okay? So I'm not able to see the exact faces of yours, but this much I'm pretty much sure that these are the girls and this is the boy sitting over there, right? Okay then. So all of these are the minus I groups. So you can do these types of questions, right? Whenever any group is written, you can identify which is the plus I and which is the minus I, okay? Okay then. Let's talk about now the inductive effect is clear, and just take care that inductive is a distance dependent. As you were going away to the carbon, the effect get neglected. So just keep this thing in the mind that the inductive effect is a distance dependent, okay? Now let's talk about the very next term and a very interesting, resonance. Now tell me how many of you understand resonance. Raise your hands. Okay, so I guess you people understand what is the resonance. It is the delocalization of pi bonds, It is the delocalization of pi electrons you can write, or pi bonds you can write. Now I'm drawing your favorite structure. You people will tell me the name. What is this? How many of you know it? Raise your hands. I know that you know this. All of you know. Very nice. So this is benzene, right? Okay, see, I am going to draw one more benzene here. I am drawing the benzene like this. Let us draw it in a good way. If I ask you the question that students just draw the benzene in your notebook, let's say the one student has drawn like the first structure, the other student has drawn like the second structure, okay? And when I will be drawing it over here, then let's say I would draw it like this. Can you tell me what is the difference between all three benzenes? Or which is the exact and a real benzene? Just tell me. Which is the real benzene? All of them are real, ma'am. You can take any of the one which you like. Is that so? All are same. Or anybody having any specific choices, raise your hands. See, when I'm asking you this question, Shillong, that which is the real benzene, it means I'm asking that in, that what actual structure exists for the benzene. You will say this last one, okay? The last one structure is the actual structure. These first two are the hypothetical structures. You know that. Like I know that the formula for the benzene is 6C6H6. But, this is the resonance hybrid. This structure is called as the hybrid, right? And the hybrid is the real structure. This is the real structure. These two are the resonating structures. These two are the resonating structures and these are the hypothetical structure. Then why we draw the hypothetical structure? Why we are not drawing only the real one? Because to understand the properties of a real benzene, it is very important to understand their hypothetical structures, okay? And, okay, tell me one more thing. How many pi electrons are present in benzene? Tell me. How many pi electrons are there in the benzene, Shillong? 3. How many of you say 3 is the answer? I know that because this is the first, usually students say 3. But I have asked you not the pi bonds. I have asked you how many pi electrons are there. Now what will be the answer, Shillong? 3 or 6? Pi bonds are 3, no doubt. But pi electrons are how many? 6. Look at the screen. Just look at the screen. This is 1, 2, 3, 4, 5, 6. Okay, so 6 electrons are evolving. If I ask you the question, tell me the number of bonds, then you can say, yes ma'am, 3 is the answer. Okay, so we can write here that 6 pi electron density is present in the benzene ring. Okay, so it means benzene has a very good amount of the electron density in itself. Now what happened here is, that if you draw the C6H6, obviously this will be the structure, but these pi bonds are not fixed at one position. They are revolving, okay. It means these pi bonds are partially present all over there in the structure. That is why we draw it like this one. I am saying that these pi bonds are not fixed. They are present all over there in the structure like this. That is why we used to draw a ring between in the benzene, okay. You know what happened with me in one class when I was teaching, not of the ALS actually. One student asked me the question that, ma'am, when I have drawn this structure on the board, he, stood up and, he pointed out and he said, ma'am, why you have drawn this oxygen between the benzene? Okay, so then I was a little shocked that, how the oxygen is there or what mistake I have done. So this is not the oxygen between the benzene, okay. This is the delocalization which we are showing, okay. So this is the case. You understand this thing, right? You understand the bond lengths and the bond order also. I guess these are the terms from the chemical bonding chapter actually. But actually what happened is that we can say that all of the bond length of the benzene are equal. Or just tell me, okay, how many of you understand the word bond length? Then I will explain it if you don't know that. You know what is a bond length? Raise your hands, how many of you know this thing? Just raise your hand if you know bond length. Nothing, it's very simple. The name actually depicts the length of the bond. Simple, okay? The length of the bond is the bond length, okay? Okay, if you don't know, then we'll discuss it later on. Let's not discuss it here. Let's keep it to the resonance and resonating structure. Now tell me that the resonating structure and resonance hybrid is clear to everyone. If I ask you, like, this was the question last to last year in the exam, and they asked that how many resonating structure will be possible for this compound. So this type of question they sometimes ask in the exam. Okay, so it's important that you should know how to draw the resonating structure. So if I ask you the question that how many resonating structure are possible for the benzene, sometimes the student give me the answer, ma'am, 5 will be possible. No, it's not like that. Okay, only 2 resonating structures are possible for the benzene. Okay, so just remember that. You want the difference between the structures and the hybrid? I will explain it, okay? See, what happened in this case, if I ask you to draw the structure for C6H6 in a cyclic way, okay? So what you can do, you can simply draw a structure like this one. We know this thing, okay, that pi bonds are fixed. We used to draw the structure like this. But what I am saying, Shillong, that what actually happened, these pi bonds keep on rotating, okay? These keep on changing the position. Like one is this possibility, the other is this possibility, okay? Like this one. So I am saying that complete pi bond is not present all over there in the structure. There is not a complete pi bond. We can say that we have a partial bond. That actually what is happening, a partial bond is present. That is why we are drawing it as a dotted line like this, okay? What I am saying that we are having a partial bond. Partial bond is present, partial pi bond is present, but that is present all over there in the structure. So this type of structure is known as the hybrid, okay? And don't worry, we will do the examples now, then it will get more clear, okay, Shillong? So let's do some of the more examples, then it will get more clear to you, okay? But just tell me if this is clear, that how you will be drawing the benzene. I hope the structures of the benzene is clear. Is it okay or not? Tell me. Okay, that is nice. Now, how you people will get to know that which structure will have the resonance and which will not have the resonance. There are certain conditions for the resonance to occur in a compound. So let's write those conditions. Conditions for resonance. To be present in any structure. Here I am going to write the 2 points here, but you will get to know about them more when we will do the example. Just after this we will be doing the examples, okay? So the very first thing is, the compound should be planar. Or you can write the molecule. It should be planar. We cannot have the resonance in a non-planar compound, okay? Then it will be very difficult to delocalize the electrons. So you will always see, you will have the system like a sp2 hybridized or sp hybridized. You cannot have the resonance in the sp3 kind of system, okay? And you can write the charge should be conserved. Just write them, we are just doing the examples and then you will get to know them. Let's start with the examples. Like I am just writing the examples, that how you will get to know that where there will be resonance and where there will be no resonance. And tell me one more thing. This is how we will be going to learn to draw the resonating structures, right? How many of you already know that how to draw the resonating structures? Tell me, you have any idea how to draw the resonating structures? Okay, the boy knows. Girls? Okay, then we will going to learn it today, right? So the first one, I'm writing the very first type. It is the positive charge delocalizing with double bond. I can write a multiple bond over here, so it's your choice. I'm just taking an example of the double bond, that is why I have written double bond. You can write the triple bond or the multiple bond as well, okay? So we have a positive charge which is delocalizing with the double bond. Now look at this screen, Shillong. Look at here. I'm drawing the bond line structure, okay? I hope you are comfortable with the bond line. You understand this thing, na? This is nothing but one carbon, carbon and carbon, and you can complete the hydrogen also, okay? How many of you understand the bond line? Raise your hands. Both these two structures are clear. How many of you know the bond line form? This is nothing but a bond line, like this is a zigzag structure when I'm drawing. It means I am drawing the carbon here, okay? I'm taking the carbons here. Okay, don't worry, let's not draw the bond line. It will create the confusion. Okay, look at the screen. Now we have to delocalize a positive charge with the double bonded system, okay? Look at the screen, everyone. CH2 double bond CH, and here I am having a CH2 plus. Are you able to see the resonance here? Excuse me. Are you able to see the resonance here? Like if I ask you to draw the resonating structure of this compound, okay? See how to draw the resonating structure. Look at here on the screen, Shillong. See, I have a double bonded system, and next to that I have a positive charge, okay? So you have to break the bond this time. Look at the screen how you will be doing it. I am drawing a rough structure here at the below. CH2, CH and CH2 plus was there. There was one pi bond, break that pi bond. Like we have done the heterolytic fission now, do the heterolytic fission. Now tell me how will you break the bond? You will break the bond in such a way, I am breaking that pi bond in such a way that here I will be getting a negative charge and here I will be getting a positive. I have broken the bond and I got the charges here, okay? Why I have broken the bonds in such a way? Because I know that this plus and this minus, now they can form a new bond, okay? So what will be the structure I will be getting? It will be CH2, CH double bond CH2, and this is now the positive charge, okay? So now the red one and the blue one are the resonating structure with each other. This is not the resonating structure. This is a rough structure which I have drawn to make the things clear to you, okay? So when we have a positive charge and next to that we have a double bond, break the bond in such a way that you will be forming a new bond ahead, okay? So this is the resonating structure. Now we can draw the hybrid also, okay? I can draw the hybrid also. See, look at the screen, I am drawing the hybrid structure here. Hybrid looks like this. Usually, when we draw two resonating structures, we draw this type of arrow in between, this arrow, double-sided. And when I'm going to draw the hybrid, it will be like the kind of dash are there. And, I can draw it like this one, CH2, CH. Now see, my pi bond is delocalizing. So I can, just draw the dotted lines here. It means that this pi bond is present at both the sides. That is why I have drawn the dotted line. Also, my positive charge is delocalizing. So you can draw delta plus and delta plus. Okay. So this is the hybrid. Although they will not be asking you the hybrid, but this is for our own knowledge. Okay. Is this clear? Any doubt to anyone in the first type? Anyone having doubt, raise your hands. Clear? So I guess this is clear. And see, I have just written here, you know that we have just written that charge should be conserved. See, this structure was the positive charge. So if I'm going to draw the resonating structure of the compound, I will be getting the positive charge again, okay? So let's say if I'm drawing the resonating structure and I started from the positive charge and I just get the negative. It means you have done the mistake, okay? So please make sure that your charges should be same on all of the different structures, okay? So let's write the second one. It's an again easy one. Let's do for the negative this time. Negative charge delocalizing with double bond. Negative charge delocalizing with double bond. Now I guess you people can do this by your own also. Try this one Shillong, then I will write, okay? So I have a CH2 negative this time. Can you draw the resonating structure of this one? Same way. Break the pi bond in such a way that you will be getting the next pi bond there. And raise your hands, those who are done with the structure. Are you getting how to draw the structure? How many of you are done? How many of you are getting it? Raise your hands. Or those who are not getting, look at the screen. Okay, no problem, look at the screen. See, so now this time we have to break this bond, right? I'm drawing a rough structure. And you can also draw the rough structure. This is for your own convenience. See, I already have the negative charge. These are the things which I already have. Now I will broke the bond in such a way that I will be getting the plus here and a minus here, okay? So I am just breaking it like that. I will be getting a plus and a minus in such a way that now I will be able to draw the bond here. CH2, CH, double bond CH2, and here I get a negative charge, okay? It's a very similar way. And in the same way you can draw the hybrid also. CH2, just draw the hybrid also. So I will be having dotted here and I will be having delta minus and delta minus, okay? Okay, so what we have done, we have done the two types. One is the positive with the double bond, one is the negative with the double bond. And the resonance is also present in the free radical. So let's say we have a free radical delocalizing with the double bond. It's again the same way. The only thing is that this time we will be doing a homolytic fission. Let's say I'm drawing the structure here, CH2 double bond CH, CH2 with the radical here. Can you people do it by your own? Just try. Give a try. Now this time broke the pi bond by having the radicals at both the sides, okay? And the older radical and the new radical just form a new bond. Try it, then I will do it. You have to do the homolytic fission in this case. How many of you are getting it? How many of you got the structure? Or ma'am, we got the doubt but not the structure. How many of you have the doubt? Raise your hands. Nobody has the doubt. Oh ma'am, we have the doubt. Okay, look at the screen, no problem. See, this time break the bond in such a way that you will be getting the homolytic fission, right? So CH2, CH is there, and see, we already have this one. Now I have broken the bond in such a manner. Look at the screen, we have already done this thing earlier. This one. This thing I am saying, this homolytic fission, okay? Just break the bond in such a way that both the carbons you will be getting the radical. So look at here now back. Now again I will be getting one radical here and one radical here. Just tell me how many of you are clear with this thing. Raise your hands. This rough structure is clear. We have broken the bond in such a way that at both the sides I am getting the radical here, okay? So now what to do? Just form a bond with these two radicals. So you will be getting CH2 one radical, then CH double bond, CH2. The bond is formed with the help of two electrons, right? So we have just got the bond. So this is the new resonating structure. See, again the number of electrons are also conserved. Earlier I was having one single electron. In my next resonating structure again I got one single electron. So this is the rule. Now I hope the structure is clear, and same way you can draw the hybrid also, okay? We are not drawing the hybrid now. Let's talk about the next rule, number 4. Number 4 is double bond in conjugation, or double bond delocalizing with the double bond. This time we have two bonds here, okay? This is again important. Double bond delocalizing with the double bond. See, let's take an example. I have CH2, double bond CH, CH, double bond CH2. Are you able to draw the resonating structure of this one? How many of you know how to draw the resonating structure of this one? Okay, let me tell you. Look at the screen, Shillong. Look at here on the screen. See what will happen in this case. I have a double bond and one single, then again double. So double, one single, again a double. Okay. Now look at the screen. How you will be doing it? You know, you can just go in any direction this time. Let's say I am keeping the negative charge here and the positive here. What I am saying that, let's say this was the case, right? You can go in any of the direction. Let's say I'm going in this direction, so I have broken it like negative, positive. At one side I got negative, at one carbon I got positive. Now you people will tell me, what charge should be there on this carbon in order to have the bond? How should I break this particular bond? How should I break this another pi bond? What charge should be there at this carbon? Tell me. You will be breaking it such like that. You were having the positive here, you were having the negative here. Now you have to again break the bond in such a manner that you will be getting a negative here and a positive here, okay? Now in the center you got a plus, you got a minus. So you will get the structure like this. This side we have a negative, at this side we get a positive, okay? So these two are the resonating structure. The green one and the blue one are not our resonating structure. This I have drawn to make the things clear to you, okay? And just tell me if anybody having any doubt, I will explain it again. It's very simple. First, I have broken the one bond, and according to that, I have broken the second bond. In between, I get the opposite charges, and I just formed the bond in between at the two carbons. Is it clear, Shillong? And you know, if it is clear, what the students do in my 12th class. For the 12th, we have the classes here, na? When I ask them, is it clear? They show me the thumbs up, okay? So you people can also do that. Is it clear? No thumbs up is there. So this is not clear. Or you can write here on the screen also, okay? If any kind of confusion is there, you can write here. I can explain it again. So the boy at the last X, is it clear to everyone there? Because obviously you are the in charge for that keyboard now, I am asking you. So you are representing whole of your class, you know that? It's clear? Okay, that is nice. So how many points we have done? We have done the 5 points. One is the positive charge in the delocalizing with the double bond, negative with the double bond, free radical with the double bond, and double with the double bond, okay? So I hope now you people will be able to draw the resonating structures, okay? We will do the practice for that, don't worry. Let's write one more term. 5 points will be there, okay? So one more is there. Let's write the fifth one. This is very interesting. Positive charge delocalizing with lone pair. I hope you people understand what is lone pair. You all of you know that one lone pair is there in the ammonia, right? And on the water, how many lone pair are there in the water? We have studied chemical bonding. Very good. So two lone pairs are there of the oxygen. We know this thing also. Let's take an example of this one. Let's say if I have a CH2, one bond is there. Okay, I have a positive charge. And I can have, let's not have the CH2, we will have see, I have drawn a positive charge over the carbon, okay, because the valency is not completed, that's why I have drawn the positive charge. Already a double bonded system is there and oxygen have the two lone pair there, okay. Whenever you see, now you know you just learn this statement, whenever you see any positive charge, you know the positive charge is very happy when it have the lone pair in its neighborhood, okay. Like when a positive charge have the lone pair in its neighborhood, then the positive charge becomes so happy in its world, okay, because it's the dream come true for the positive charge. Why? Because it becomes so much stable there. Now what I can do, I know that this is the positive charge and this is the lone pair. So we can draw the resonating structure like this, that this positive and this lone pair can form a pi bond here, okay? They can form a pi bond, and oxygen has given the lone pair. That is why the positive charge will delocalize over the oxygen. I hope you people know this thing, the oxygen generally has like this type of structure is there, okay? So oxygen usually make two bonds with two lone pair. In any of the case, if you are making any structure like this, any one more bond, whenever oxygen makes the three bond, always keep this thing in mind that it will have the positive charge over itself, okay? The reason is because the oxygen has given its lone pair that my lone pair you should go and you are forming the bond, so that is why it will have the positive charge, okay? So this is the another case. We have the positive charge, we have the lone pair, they are just making the bond, okay? Both of them are making the bond, and the positive charge will go over to the oxygen. Is it clear or any doubt is there? Quickly revise all the 5 points, then we'll do the questions, okay? And if anybody having any doubt, raise your hands, and you have the keyboard there, you can write it down, okay? From the screen, you people are looking like, so studious kids. Ma'am has given the instruction to read the points and everybody is reading. I'm so happy. Or, no ma'am, this is the first class, that is why we are reading only. So done? Any doubts along? If you have any doubt, just write it down, and if you don't have any doubt, then also please write it down. So is there any doubt? The boy at the last. You and your class, okay, no doubts are there, okay? That is nice. So let's do some questions, okay? So you people will be drawing the resonating structures. You can write the question, draw the resonating structures for the following. Draw the resonating structures for the following. Just draw the resonating structure of this compound. try this question and you people will tell me that how many resonating structures you are getting, okay? Try this one and you will be telling me that how many resonating structures you are getting. What is the answer, Shillong? How many structures you are getting? Two structures? Everybody is getting two structure? Yes, two is the answer. See, look at the screen, how we will be doing it. Now, you can just draw a rough structure here. Like we have a CH3, we have a CH. This is the same question which we have done earlier. The only thing is that I have attached one methyl here, okay? But that is not an issue. So I already have the positive charge. You will break the bonds like this. The direction of the arrow shows my negative charge, okay? That this side I have the negative, this side I will have the positive. If I want to draw the structure complete here, we'll have a double bond. What we can do, we can have a positive here and we can have a double bond like this, okay? So this is the resonating structure for this compound, okay? So anybody having any doubt, you can just write it down here. Then let's try for this question also. I am now going to draw this particular structure in the bond line form. This is a bond line form, okay? So we can have a negative charge here. I hope you understand this thing. This is nothing but a structure like this one, that I haven't drawn the carbon and the hydrogens, okay? So this is known as a bond line form. In the bond line form, we usually don't draw the carbons and the hydrogen. So look at the screen. See, this is actually, this structure is here, okay? That we already have a pi bond here, and if I want to make, these are the hydrogens, I know that carbon has the 4 valency. So this is this kind of structure. But in the bond line, we usually do not show the carbon and the hydrogen bond. So this is nothing but the same way. Okay, so you can just make the structure here. Try to make it in the bond line, okay, because many times in the exams they will give you these bond line forms. The zigzag carbons will be given to you. Tell me what is the answer you are getting for the second one. Two structures you are getting? Yes, this is correct. Good. So how many of you are getting two structures? Okay. The boy got it from the girl side. See how you will be drawing now. Look at the screen. Let's say I'm drawing here the rough structure here. This is the structure. This was the already negative charge. You have to break this pi bond. And how you will be breaking it? Just make sure that you will be breaking it like plus and the minus, okay? Because this plus and minus will make a bond now. When you make the exact structure, this plus and the minus will make a bond like this. And we already get what charge here? A negative, okay? So this is the resonating structure. No need to go here on these carbons, because I have just given these carbons for the confusion, okay, so that they will confuse you. So you already know that you have the resonance only in this region, only in, not actually in this one. You have the resonance only in this region. This is what I am saying. A negative charge is in delocalization with the negative, a double bond is in the delocalization with the negative charge, okay. Now you got it? Anybody having any doubt? Girls, you have any doubt? Okay, so I think there is no doubt, but still if you have any, okay, don't feel shy or anything. Just write it down or simply raise your hands, okay? Because you know that you are, because if you have the doubt and if you will not speak it up, then obviously how will I get to know? And it's very, very important to clear all your doubts, okay? So let's talk about one more question, number 3. Now this time, this is the structure, okay? Try it. I'm giving you a hint that you already have the positive charge, so break the pi bond next to the positive charge. Break the pi bond next to the positive charge and then check how many structures you are getting. How many structures you are getting? Only one. But that one structure is this one which I have given you. Obviously there will be some more structures. And Shillong, when I'm asking that how many structures you are getting, you will be counting this structure also, okay? So you have to count the existing structure also, or else they will write it in the question that including the given structure you have to tell the answer, or excluding the given structure you have to tell the answer. Girls, you got the structure? Look at the screen, okay? Many times students used to say that, ma'am, only one more structure will be there. But they miss one structure, Look at the screen. See, I know that I will be breaking this bond, and how I will be breaking it? Keep this bond fixed. Just fix this bond and you are showing the resonance of this one only. A positive charge delocalizing with the double bond. And how we will be doing it? We were already having the plus here. So I can draw a minus and a plus. Okay. So I have just broken one bond from the center. I got the minus, I got the plus. Now you people will tell me what will I get? See, I got, this is the fixed one, this is the positive, Now this plus and this minus, what will they do? They will make a bond, okay? So I'm just making a bond here and I got the positive charge here at the center. Are you getting it? What I have done, because I already, initially I was having this plus charge, na? So I have just broken the bond. This blue color signs are showing the bond breakage of the center one, okay? So I give the negative here, I give the positive here. Now these plus and minus are making the bond like this, okay? So this is the one structure which I got. Now again look at the screen. One more is possible, because this time I will be showing the conjugation with the next pi bond. How? Look at the screen again. I am drawing a rough structure. This is the fixed one now. This was the positive charge and I will be breaking this bond this time. And there I will get a negative and I will get a positive. So what will be the exact structure here? It will be like this. A double, and here I will get a positive. So these three structure will be the answer. So 3 is the answer. This question was a little tricky and a confusing one. So just write it down and please make sure that you are getting it. The red one, the structures which I have drawn with the red color are the structures which I have drawn to make the things understandable to you. Our exact structures are these dark color structures, okay? Any doubt, anyone? So the answer will be 3, okay, Shillong? And when I teach the resonating structures in the class, obviously, for the first time, it is sometimes, students do find it a little bit difficult. These are not actually difficult. But as you do the practice, when you just repeat these questions once you go home, once you try more questions which I will give you in the assignment, then definitely, everything will be in the flow and you will directly draw the structure. Then, there will be no need to draw these rough structure which I have drawn in the red color. Because then you will automatically know how to draw them. Then, you will get all of the answers. Is it clear? Let's do one more then. Number 4. Number 4 was this question? Okay, no. Let's do in the cyclic structure, okay? This is an easy one. You can do by your own also. Let's say I have a double bond here and here I have a positive charge. This is cyclohexane. A double bond is there, a positive charge is there. Draw the structure. Break the pi bond, get your charges and then form the new bond. How many of you got the answer? Have you drawn the structure? Okay. Girls, you got it? Okay, look at the screen. I am drawing the structure here. See what will happen. Let's draw the rough structure first of all. So this is the positive charge and you can just break the bond such like that. You will be getting a negative here and a positive here. So what will be the answer of the question? You will get a pi bond this time and you will get a positive charge like this, okay? How many of you got the same structure as in the blue color I have drawn on the screen? Raise your hands. Okay, that is nice. Good. Now try one more. Okay, so you are comfortable, I guess, with when you have one single bond and the charge. So you are good with this one, okay? But it's important to draw the structures like whenever you are having more charges, okay? Try this one also. We have, what happened, Shillong? Opposite way, in which way? You get any other answer from this one, blue color structure? But the answer will be this blue color one, okay? Okay, you can try this one also. You can try this one, this question. Oh, I'm so sorry. This is a cyclopropane, right? This is not a triangle. We know that. We are not studying the maths here. This is a cyclopropane. There is a double bond, and here you have a positive charge. Do this one and take care, okay? And tell me how many resonating structure you will get in this case. Got the answer? How many structures, Shillong? How many of you got the answer? Raise your hands. Okay. One girl got the answer only. 3 structures. So you got 3 structures? How many of you got 3 as the answer? Look, raise your hands. Yes, 3 is the correct answer. Good. See, look at the screen. It's very simple again, okay? So you can draw the rough structures. This was the plus. You can break it in any direction. This time you can break the bond in any direction. Let's say this is the minus and this is the plus. So what I will be getting, I will get a pi bond here and this time a positive. And one more is possible here. Why one more is possible? Because there is the possibility to have the pi bond at the another different carbon. So if I break the bond again, what I will be getting? This was the original plus, and this time I will be writing it as the minus and the plus. Okay, so what I will be getting? I will be getting the structure like this. Okay, so this is the structure. So how many of structures we are getting? We are getting 3 structures. And Shillong, you can make the hybrid also. This time the hybrid will look like this one. See, the dotted, you can make a ring. Okay, you can just make a ring. It's a dotted structure and a delta plus will be written in between. Many times in the books they will write the hybrid. Okay, so do not get confused. This is nothing but they have drawn the resonance hybrid with the delta plus charge. Any doubt? Anybody having any doubt? Is it clear? No doubts. Okay. Okay. Let's have one more structure and then we'll have a break. Okay. And we will have a 5 to 10 minutes because it's a 3-hour class now. I know that you people will also want the break and I too want a break. I'm speaking since morning. Classes were there in the morning. So we will have a 5-10 minutes break. Okay. And then we will discuss it more. Meanwhile, you can try now this question. This is again a good question. Okay. Just try it. try this question, and you can try this in break, or we can just, take a break for 5 to 10 minutes. 10 minutes break will be there. If you want, you can just try this right now in the break. Okay, so I guess you people are writing the question. You people can practice it. We will discuss the answer after the break. Okay, let's have a 10-minute break. You can also relax, and then we will discuss the answers. Okay? Okay then. Okay, so Shillong, how many structures you got for that question? You tried that question? Or no, ma'am, we were on the break. You were on the break, so we were also on the break. Let's see that question. See, in this question, what was happening now? We have the two pi bonds here in this structure, okay? So sometimes students do get confused at what to do in this type of case. So, the very simple approach is always keep one pi bond fixed and delocalize the another one, okay? How many of you got the structure? How many of you got the answers? Raise your hands. Okay, just let's look at the screen. I know that you people got some of these structures, but you are not sure that this is correct or not. Okay. See, let me draw here the rough structure. This is our rough structure. Let me keep this pi bond fixed. Okay, this is the fixed bond. So I already have the positive charge here. I have broken this bond. I am getting a negative. I got a positive. Okay. So I have just broken one pi bond. I got the charges. So what will be the new structure now? The new structure will look like this one, okay? This is a pi bond, you get one pi bond here and this is the positive charge, okay? So this is the resonating structure. So it means, what we are doing? We are just making the resonating structure of one pi bond and one positive charge, keeping the next pi bond as the fixed one, okay? So now let's draw the one more structure for this one. I'm drawing here the rough structure. So this time I am keeping fixed the bond which I have already just made, okay? So this is the bond and this is the positive. Now let's break this pi bond in such a way that I will be getting a negative here and I will be getting a positive here. So what will be the next structure? It will look like this one. It will be a pi bond here, a new pi bond here, and this time you get a positive charge here. So, similarly, you can just delocalize that particular positive charge all over there in the structure, right? So, you can just delocalize it all over there in the structure. One more is possible. Now, how will you get to know that? Till far you have to keep on drawing the structures. Till you get the similar structure, you will be drawing all of the structures, okay? See, now let me draw one more. A rough structure I am drawing here. So this time I have this double bond, I have this positive charge. I will, break the bond like this is the negative, this is the positive. So what will I get here? I'm making the fresh structure here, a pi bond, double bond and the positive again. One more if you try, the one more time if you try, then you will be getting, this is the positive. I'm breaking it again. If let's say I get a negative here, a positive here, then you will get one more structure. 5 is actually the answer, because 5 carbon cyclic ring, 5-membered cyclic ring is there. At every position you are getting the delocalization. So 5 times, the positive charge will delocalize in all of the 5 carbons. That is why you will get 5 as the answer. So this time I will have a double bond here and you can have a double bond here and this is the positive. And if you try one more time, you will get back the same structure, okay? So you will get back the same structure. That is why I am not drawing that. The answer is 5. These are the 5 structures. 1, 2, 3, 4 and 5, okay? So 5 is the answer. Try them. If you have doubt, you can ask me. And it is very, very important to draw the structures again at your home, okay? But still having doubt, so you can ask me. Is it clear to you, Shillong? Any doubt to anyone? Girls, is it clear? To the boys, is it clear? Okay. So I hope everyone is clear with these structures. I am drawing one structure. You can draw it in your homework. This is the homework question. and the rest of the structure we will be drawing right now. Okay, this time I have just given you a negative charge. Okay, and a similar kind of thing will be there. Earlier you were having the positive, this time I have given you a negative charge. Okay, so just try these, the resonating structure with the negative charge. And one more important type of question that we will be doing right now. Number, which was the number? 6 was the number, na? So 7 is the homework. 7 is the homework. I'm drawing the number 8. I'm drawing it here below. First of all, you people will tell me the name of this compound. Let's say if I have a oxygen with the negative charge. Negative charge means I have 3 lone pairs this time, okay? So I'm not drawing the lone pairs, I am just drawing a negative charge here. If I have a negative charge, it means 3 lone pairs are there, okay? And you know this structure, you have done the reactions with this structure. Can you tell me what is the name of the compound which I have drawn on the screen? How many of you know? Raise your hands. Okay, tell me this thing also. How many of you are aware with this one? How many of you know about this one? Okay, so all of you know this is phenol. Very nice. So this is phenol, we all know that. Now what I have done in this case, I have just removed the hydrogen here. You know that there are the questions of acidic strength. What is an acid? Acid gives their H plus, right? So phenol is also an acid. Phenol is giving the H plus, so that is why it is having the negative charge. So I can say that this is an anion of the phenol, okay? And what is the name? The name is phenoxide. Remember these names, these are very common, okay? So this is nothing but phenoxide. Now can you people draw the resonating structure of this one, phenoxide? Look at the screen, I am drawing the structure, okay? Look at the screen. It's important to draw the resonating. You used to say this thing, na? That phenol is a very good acid. Not so good acid, but actually it's an acid, we can say that. So just by removing the H plus, this negative charge which you get on the oxygen is stabilized by the resonance. This negative charge can delocalize in the benzene ring, okay? How it can delocalize? Just look at the screen. See, keep these 2 bonds fixed, and this is the oxygen here. Now how will you do it? I am drawing one rough structure here for you people. This was the O minus, everyone. Just look at the screen. We are breaking this bond first. If I break this 1 pi bond, I will get a positive here and a negative here, okay? So I get a negative charge in the ring. This plus and minus will make a bond and I get a negative here, okay? And similarly you can draw the rest of the structures also. So let's say I am drawing it here now. This time I am keeping fixed these 2 pi bonds. Now this is the negative and this is the pi bond. How will you draw the resonating structure? You will put the negative this time here. See, first of all, look. This is the negative. I am breaking this bond. I get a negative here. I will get a positive here. Now this negative and this positive will make a bond. I am not drawing the rough structure. I am just drawing directly the resonating structure like this one. Okay, this is the charge. One more will be possible. How it will be possible? Now put the electrons here. Just keep fixed these 2 pi bonds. Okay. Now this time I will get a bond here and a negative here. One more is possible. How? This time you will give the electrons back to the oxygen. So you will be getting a benzene again with the O negative. So these are the 5 structures which are possible in the case of phenoxide. Just draw them. If anybody having any doubt, then you can ask me. And just take care that I haven't drawn the rough structures, okay? That you can draw by yourself. But still, if there is doubt, Just let me know. I will draw the rough structures again. So what is the answer? You can write 5 is the answer, okay? This is the rough one. The 4 structure in the red color and the one with the blue color is our answer, okay? 5 is the answer, not 6. Is it clear, Shillong, everyone? Girls, is it okay? When this is okay, now you can just show me the thumbs up, okay? So is it clear? Okay. The boy is showing the thumbs up. Why not the girls are showing the thumbs up? This is not clear to the girls. Okay, so I am assuming that this is clear to everyone there. But if my assumption is wrong, please write it down, okay? So this is the way how you will be drawing the resonating structure. This is the example. And one more question that you will do in the homework. One I have, shown here in the class with the negative charge. I am giving you one. You can practice it in the homework. Here you can have the CH2 plus. This time I have the positive charge, right? This time I have the positive charge. Do you understand? This is a carbocation. Have you heard about this term, carbocation? How many of you know what is carbocation? Raise your hands. This is a common term, or you have heard it. The carbon which is having the positive charge is the carbocation, right? So we have the carbon and it is having the positive charge, that is the carbocation. When a carbon is having the negative charge, that is a carboanion, right? So carbocations, carbanions, these are the intermediates, okay? So these get formed in between, okay? Intermediate is anything which is formed in between of any reaction, okay? So we will discuss the intermediates also, because direct questions are there in the competition, and they will ask you to write down the stability orders for the carbocation, write down the reactivity orders for the carbocations, and these you will judge with the help of these effects which we are studying right now. Like you can judge with the help of the resonance, you can judge with the help of the inductive effect, and then the hyperconjugation. That is why it's very, very important to study these effects first. Because when we will be dealing with any reaction, like I hope you people have studied SN1 reaction. SN1 mechanism you have done, SN2 mechanism you have done. Have you done SN1, SN2 in your 12th class? It was there in the boards. Nucleophilic substitution reactions. How many of you have heard about these reactions? Raise your hands. SN1, SN2. All of you know that, okay? So you know that in the SN1 you got the carbocation, you know that, okay? So like there will be the questions that in which of the following the rate of SN1 will be faster. So these type of question will be there. Or they will give you the 4 options and they will ask you to write down the order for the rate of the reaction. So you have to judge it with the help of the stability of an intermediate, that is the carbocation. And that is judged with the help of these effects, the resonance and inductive. So if you don't know them properly, so that will cause a problem later on, and then you will not be able to solve those questions which are there in the exam. Okay. So just make sure that you people will be practicing all of these questions which we have done today regarding the resonating structure, right? Now let's come to the next thing. Okay, let me ask you some of the more questions related to the resonating structure. So if I say, this is the benzene, let's talk about the compounds of the benzene. So how many resonating structure of the benzene is possible? You can simply say, ma'am, 2 resonating structures are possible. The answer is 2. Okay, do you know about this compound? Have you heard about the name? What is this? The bigger brother of the benzene. Now we have 2 benzenes together. How many of you know the name? Raise your hands. You know the name, I know that. No, it's not toluene, Shillong. Toluene is when you have benzene and methyl is over that. That was the toluene. Okay, are you giving me the name of this compound, this one? This is not the toluene. Toluene is this one. Benzene with methyl, okay, that is the toluene. Now tell me if you have any idea with this one. The bigger brother of benzene. Yes, Shillong, any idea? Girls? Girls are thinking, I know that. No, ma'am, we don't have the idea. This is naphthalene, okay? See, this is the benzene. The bigger brother of benzene, always remember that. Very common questions. Naphthalene. Okay, this is naphthalene. Or if I ask you the question, what will be or how many resonating structures are possible for the naphthalene? There is a trick, So you can just follow that trick and you will get the resonating structure. Look at the screen. Whenever you see these type of compounds that benzenes are combining together, then how to find the number of resonating structure? You can just fix the bond. Look at the screen. Like in the benzene, first of all, we fix the bond here at one side, fix a bond and have the alternate pi bonds, okay? So like this one, I can just fix a bond here and then I can draw the alternate pi bonds, okay? And for the next structure, I can fix a bond here. Look at the screen, we have a pi bond here. So similarly, you can just fix the bond in same way, okay? And you will be getting the resonating structure. Now just applying by applying this trick, can you tell me what will be the answer in naphthalene? How many resonating structure will be possible in the naphthalene? Think about it. Fix a bond, you get a structure. Now fix another bond, you will get a structure. Think about it. Okay, and you can have the guesses. I won't mind getting the wrong answers also. I just want the answers, obviously. How many pi bonds will be, how many resonating structures will be possible in naphthalene? Just write down 2 or 3 or 4. See, I'm giving you the options also. I'm saying that you can apply this trick, na? You can just fix one pi bond and then you can draw the alternate bonds. Any ideas along? 4 or 3? Look at the screen. See, let's say in this structure, this one pi bond is fixed, okay? Now, can I draw one more structure here? Now, I will be fixing my pi bond in this way. Look at the screen, Shillong. This is the pi bond which I have fixed, and the rest of the pi bonds you can draw, okay? And like rest of the pi bonds, I'm drawing like this. I'm saying that you can have the alternate pi bonds. Now, let's have the one more. 3 will be the answer, na? Now, I am fixing the pi bond in this way. I'm saying that you can just fix the bonds which are drawn in the blue color. Once you fix the bond, the rest of the bonds will be drawn in the alternate way. Okay. So no problem. I can draw the rest of the bonds in the alternate way. Alternate, you understand, na? Leave one bond and then draw the pi bond at the next carbon. So you can just draw it like this one. So the answer for the naphthalene is the total resonating structure will be 3. Just have a look on the screen, Shillong. Write it down in your notebooks and then tell me if you have any kind of doubt. And these are so direct questions. That is why we are doing it. If somebody asks you the question, how many resonating structures are possible for the naphthalene? You will say the answer is 3. No need to even draw them. Okay. Is it clear? Shillong Center. Just write down if it is clear. Okay, I have one more. Bigger brother of naphthalene. You know, these are the 3 brothers. So just remember them. One is the benzene, another is the naphthalene, and one more is there in the category. First of all, do you have any idea for the name of this one? If I have 3 benzenes. This is anthracene. Okay. This is anthracene. Benzene, naphthalene and anthracene. Now you people will tell me what will be the answer for the resonating structure. Apply the same trick and then tell me the answer. How many resonating structures are possible in anthracene? Yes, Shillong, that is nice. So 4 will be the answer. So you can fix that particular bonds in 4 directions, or I can say in the 4 possible ways. So what will be the answer in this case? See, I am drawing the structures here. I'm drawing the fixed one with the blue color. Let's say I have fixed this one here. Now I'm fixing it here, okay? And then you can just draw the rest of the pi bonds. You can draw all of the 4 structures. Now I am fixing the pi bond in this direction. In this way here, okay? And all the rest will be my like this. One more is the possibility. This time I can fix the bond in this direction here like this, okay? And we can have the alternate bonds. Okay, so this is the answer. So we can say that in anthracene, the 4 is the answer. So this is clear. I hope this is clear. So we have done, how many things we have done? Without looking at the notebook, Shillong. The first one is we have studied what is the inductive effect. Now we know what is the resonance. We know what is resonance hybrid. We know what are resonating structures. And we know the 5 types of resonance. Positive charge in conjugation with double. Negative charge in conjugation with double. Radical is in conjugation with double. Double bond in conjugation with double, and then a positive charge with the lone pair. Okay, these were the 5 types and these were the questions. So we have done We also know how to draw the resonating structures, okay? And these were the special cases of the benzene brothers. So benzene is there, naphthalene is there, anthracene, okay? So now remember them. These sometimes they ask these things in the exam. Now the next topic. Let's start the next topic. That is again related with the resonance, okay? And this is again an important thing. Stability. Like, what happen is they will ask you two compounds will be given, which is more stable. I am here talking about the stability of resonating structure. We learn how to draw the resonating structure. Now, which structure is more stable and which is lesser stable? We are dealing with these questions. Stability of resonating structures. And I think you people have some idea about it, and you people have studied it earlier also. How many of you have the idea related to this one? Just raise your hands. How to check the stability for resonating structures? Do you have any ideas along? No, we don't have the idea. That is okay, no problem. So how to check, the stability rule? Let's write the first point. And the order which I am following here, you have to follow the same order. You cannot apply the fourth point in the very first way. No. The very first thing is, whenever we have the two resonating structures, we first of all check for the pi bonds. The structure with the more number of pi bond, or we can say the structure which is having the complete octet is more stable, okay? You already know what is the octet. Octet means that 8 electrons are present in the valence shell. So the structure which is completing the octet will be the more stable. So these points are important. Let's write. If two resonating structures are given, or we can simply write the resonating structure with more number of pi bonds, or you can write complete octet. Is more stable. Let's write an example. Let's say if I have CH3, CH with the positive charge, and like this. And I'm drawing the resonating structure of this compound, or you can also draw it by your own. Let's say I have a C. Wait. Just draw one single bond here, okay? Draw one single bond, or we can draw it here OH. That would be much easy. Like this. You can just draw the OH here. So if I just draw the resonating structure of this one, it would be like this. You remember, this is the fifth type of resonance, fifth type of delocalization, when the positive charge is delocalizing with the lone pair. This is this type, okay? Now a positive charge is there and the lone pair is there. Now you people will tell me, Shillong, I have this first structure, this is the second, which is the more stable. Now, if I directly give you this question without telling you the rules, many of the students do the mistake. What they do, they say that, ma'am, first one will be the more stable because in the second structure you have the positive charge on the oxygen. We know that oxygen is electronegative atom, so we cannot have the positive charge there. Although this point is correct, that electronegative atoms generally do not want the positive charge over themselves. But the important thing is the octet. Just check the first structure and the second structure. In the second structure, the octet of the carbon is completed, right? So either you can go by the number of pi bonds also. In the first structure there is no pi bond, but in the second structure we have one pi bond. So which will be the more stable? What will be the stability order? Tell me, Shillong. How many of you say that second is more stable? So second will be more stable, right? Because it has the more number of pi bond. So second will be more stable as compared to first, okay? So whenever you see any type of question in which you have to check the stability of the resonating structure, you will first of all check for the number of pi bonds. The structure with the more number of pi bonds will be the more stable structure. Clear? The first point is clear to everyone? I hope this is clear. Let's write the second point then. See, what if let's say I have the two structures, but both of them have the same number of pi bond, then what will you do? If let's say I have the structure, let's say I have two structures, okay, and both of the structures have same number of pi bond, then what will you do? Then you will check for the charged and the uncharged structure, okay. So you can write if same number of pi bond are present, then check for charged and uncharged structure. The one which is having no charges or the uncharged structure will be more stable. Is it clear, Shillong? So the statement is there on the screen. The uncharged structure will be the more stable. Let me write an example and you people will tell me the answer this time. Let's say I have CH3, C double bond O, OH, okay. These are the lone pairs. So I can make the resonating structure here. Let's say I get this as the resonating structure. I'm putting the electrons, okay, like this. So I get a negative charge, I get a double bond OH, and here I get a positive. Now you people will tell me, Shillong, this is the first, this is the second. Which is the more stable structure? How many of you are saying that first is more stable? Okay. Girls? Do you think that first is more stable? Yes. So first will be the more stable, right? Because you are able to see that 1,1 pi bond is there in both of the structure, but the first structure is uncharged, okay. This is the uncharged structure. And the one which is having the charges will be lesser stable. So if I want to write the stability here, I will say first will be more stable as compared to the second. Clear? So I hope there is no doubt. So the first point is the number of pi bonds. The second point is the charge and the uncharged structure. Now what if I have, let's say, both of the structures as the charge structure, then what will be doing? First of all, let me write the example first. You people try it. Then I will write the statement. So this is the third point. But I am writing the example first, okay? So just look at the screen, Shillong. First of all, you will give me the answer. Let's say I have CH3, C double bond O, NH negative. And let's say if I draw the structure, I get a O negative and double bond NH. Think about it. So you will be applying the first point. Number of pi bonds you will check. Both of the structures have the pi bond. Then you check for the charge and uncharged structure. Both of the structures are negative charge. Now what will you do? First of all think, then I will tell you what to do. At one side there is the negative charge on nitrogen. At the another side there is the negative charge on oxygen. Now which is more stable, Shillong? This is the first structure and this is the second structure. Which is more electronegative atom, Shillong? Oxygen or nitrogen? Okay, how many of you have the guesses for the second? That second will be the more stable. Tell me. No one is saying that second will be the more stable? Or we are with the first one? Or we are with nobody, ma'am? We don't know. We have the mixed thoughts. See, okay, don't worry, listen to me. Whenever you see this type of situation, always think about the electron negativity, okay? We know that oxygen is more electronegative as compared to the nitrogen. So always remember this thing, whether you are studying, organic, inorganic or physical, these are the standard things. That more electronegative atom can always keep the negative charge over itself. Or more electronegative atom will be happy to have the negative charge. Or more electronegative atom stabilizes the negative charge, okay? So oxygen is there which is having the negative charge. So this is, I can write as the more electronegative atom stabilizes negative charge. So that is why the second will be more stable than the first one. But listen to me, the one with the statement which I am saying, that negative charge is stabilized on more electronegative atom, this is only and only valid when we are talking about the negative charge stability in a period, okay? Whenever we have the atoms of same period, you know that the oxygen is there, nitrogen is there, fluorine is there, they all of the second period, right? They all are of the same period. That is why always remember that you can check the negative charge stability with the help of electron negativity in case of the same period, okay? And one more thing, then what we will be doing in the group I will tell you. But one thing you can note it down, like many of you were not knowing that which is more electronegative. This is the order of Fonch, okay? This you can, just remember it. This is the order, like fluorine is the more electronegative, then is the oxygen, then nitrogen and then carbon. This is the most electronegative. So after the fluorine you can just write as the oxygen, then nitrogen and then carbon. Then it will be very much helpful for you, okay? So you can write it like this. Fluorine, then oxygen, then nitrogen and then carbon. This is the electron negativity order. For electron negativity, I used to write En in the short form. En I used to write. Okay, so this order will be helpful to you in many of the questions of the organic chemistry, Shillong. Okay, that whenever you will be checking for the electron negativity, generally we deal with fluorine, oxygen, nitrogen. Now don't think that ma'am you haven't written chlorine here or ma'am you haven't written sulfur here. We are only talking about the second period, okay. So generally this order will be helpful to you. Fonch, okay, so you can just remember it as Fonch. Fluorine, oxygen, nitrogen, carbon, and then hydrogen, right? So let's write the point here. We have just written the, the example. Let's write when, I'm just writing the statement for this particular point, okay? That when both the structures, when both the resonating structures are negative charge, then more electronegative atom or more En atom stabilizes the negative charge. And one more thing, just, you can write this in the bracket, that this is for when elements of same period, when elements are of same period. These are the very, very important concepts, okay? Because you will be doing these things while you are writing the reactions also. That when I will say, see, this chlorine negative is going out because this is stable, then how will you get to know that why the hell this is stable? Then you can keep this thing that Cl negative is more stable as compared to this one because it's more electronegative, okay? So these are the things. Okay, now one more very, very important thing is, because we have only talked that we will be checking the electron negativity in a period, okay? Now what will happen if I have a different elements of a group? Let's write it as the point number 4. I will be writing an example first, okay? So you people will try the question and then we'll write the statement. CH3, C double bond O, let's say here I have a sulfur. Now I am writing the element in a group. I have the oxygen and you know that below the oxygen there is the sulfur. So what will happen in this time? I have O negative here and this time I have the sulfur. Now first of all you people think about it. Then I will tell you the answer. Which is the more stable Shillong? Think about it or have some guess. First or second? First, why? Because ma'am you have said that we will not be checking the electronegativity, then the first will be the answer. The answer is correct. The first one is correct. But why? See, many times what happens is students do the same thing, because then they always remember the electronegativity funda. So they will say, ma'am, oxygen is more electronegative, it will keep the negative charge over itself, it will become more stable. But this is the very important concept. Look at the screen. Always remember that, let's say this is the oxygen, this is the sulfur, then selenium, and you can just going down the group. When you are checking the negative charge stability in a group, okay, so we check it with the help of the size, okay. Let me draw it like this one. Let's say this is the size of the oxygen having the negative charge, okay. It's a sphere, not the O, it's a sphere. I'm drawing a simple atom with the sphere. And let's say this is the sulfur. Sulfur having the bigger size than the oxygen, so this is the negative charge. Now, just think like that the bigger size atom will have the uniform distribution of the charge. Are you able to understand it? I'm saying that in a smaller one, there will be, the concentrated charge will be more. But here, the charge will be having the uniform distribution all over there in the structure, okay. So that is why we always check size when we talk about the elements of the group. We do not see the electronegativity, okay. So I am simply saying that the bigger size atom, I was just trying to make the things clear to you, okay. I am simply saying bigger size atom stabilizes negative charge. because it will have the uniform distribution, okay? Because of the uniform distribution of charge. Is this thing clear now, Shillong? Anyone having any kind of doubt, just tell me. Okay? Any doubt, Shillong? Girls, is it clear to you people? I'm waiting for the reply. So you can write it like this also, that stability order will be first is more stable as compared to the second. Okay? So whenever we have the elements, whenever the negative charge elements are of different period, okay, so you can just write it like here only. We are not writing the complete point. Or let's write, when negative charge is present on elements of different period, then check size. Okay, then you have to check size. Bigger size atom stabilizes negative charge. Now a very interesting question, Shillong, in which most of the students do get stuck, okay? Now you have, let's say, F negative, Cl negative, I'm writing halogens, Br negative and I negative. Can you tell me which is the more stable? Which anion is the more stable? F negative or I negative? Think about it. F negative and I negative. You know, if I will be asking you this question without, describing this point, definitely you people will going to answer that, ma'am, F negative is more stable due to the electron negativity, okay? But this is not the answer. Which is the more stable? If I am writing the stability order. Stability order. So what will be the stability order? You can just, write I negative first. I negative, then Br negative, then Cl negative, and then there will be F negative. The reason is size again. Because the iodine is the bigger size atom, it will be stabilizing the negative charge by having the uniform distribution, okay? Now, this is the one step that how the question can be framed. If, I will be asking the question in the exam, I will ask you this question. Which is more acidic? Or write the order for the acidic strength. Think about it. HF, HCl, HBr and HI. You know that all of these are the acids, right? And this can be the question of the inorganic chemistry also, okay? Like in the P block they ask this type of questions. So which will be more acidic? If you have to write the order, think about it so long and then tell me the answer. HF or HI? See, HF will also be there in the option and HI will be there in the option. How many of you are saying HF is the strong acid? Okay, how many of you are saying HI is the strong acid? Oh, I'm not able to see. There is the technical problem. So, how many of you are with the HI? Anybody with the HI in the class? Now raise your hand. Now I'm able to see you all. How many with the HI? Or anybody with the HCl or HBr? Or ma'am, we are with nobody. We are having the mixed thoughts. See, first of all, listen to me. This is again a very important concept. If you know any of the question is asked related to the acidic strength, like many of the questions are there, in the NEET they used to ask these questions, that write down the order of the acidic strength. Now what you have to do, how you will be solving these type of question. You know what is the work of an acid? What is the work of an acid? We know that acid gives the H plus ion, right? Whenever we talk about H2SO4, we talk about HNO3, HI, HF, all of them give the H plus ion, okay? So you have to check the acidic strength in the same way. The acid which will be giving the H plus faster, okay, that will be a very good acid because it is, dissociating the H plus ion fastly, okay? Can I say like that? The one compound which is giving the H plus ion fastly or very quickly, then that particular acid will be a very good acid. It's a very stronger acid. It means it is giving the H plus ions, okay? Now how we can check? Just remove the H plus ion from all of them. After removing the H plus ion, you will get F negative, Cl negative, Br negative and I negative, okay? Now think about it. You have the HF with you, you have the HI with you. Which one of them will be easily giving its H plus? The compound which will be forming the stable anion, okay, which will be forming the stable anion, definitely that particular compound will say, see, my H plus, you go away. I want to become a stable anion, okay. So HI will be the stronger acid, okay, or HI will be the very good acid. The reason is, because in case of HI, when the H plus go away, that particular I negative, that particular anion will becoming the more stable, okay. So HI will be the stronger acid. So if I want to write the acidic strength, this will be the order. The reason is because this is the order of stability of anion, okay. So always remember like that whenever you are comparing acidic strength, though we will be doing the question, this is also a part of GOC, General Organic Chemistry. So always remember the acidic strength is always directly proportional to the stability of anion. Or you can call it as the conjugate base also. You people have studied equilibrium. You know what is the conjugate base, okay? Like what I am saying, that if let's say I have HI, it will dissociate and becomes I negative. So if this is an acid, this is the conjugate base or this is the anion, right? Are you people getting this concept, this particular thing? Any doubt in this one? And this is the star mark thing, okay? Just this is the 5 star. Some of the topics are 5-star topics, that those are important. So any doubt that why HI is the stronger acid or why HI is the good acid? Is it clear to everyone? Too long? What is the conjugate base? You haven't studied the conjugate base. Oh, no problem. Look at the screen. Whenever we have an acid, I'm taking very simple example. Let's say we have HCl, right? I put the HCl into the water, it will dissociate into ions. I will get a cation, I will get the anion. See what happened is, if this is the acid, this particular thing is known as the conjugate base. Or you can say that the anion which you form is known as the conjugate base. So we call it as a acid-base pair, okay? Acid-base pair or acid conjugate base pair, okay? This is the topic from the ionic equilibrium, okay? So, if I want to write here like, for any of the acid you can write. Let's say I'm writing H2SO4. Can you tell me what will be the conjugate base of this one? 2H plus will go away and I will get a sulfate. This is sulfate, right? So if this is my acid, this is what? This is the conjugate. Yes, conjugate base pair. Okay, that is the easy thing. Now, okay, if we are doing this thing, you can just do this one. That stability of the resonance, almost many of the points we have covered. The only thing we are left with the examples. Okay, so don't worry for that. Think about this one. What is happening in this case? Ammonia here accepting the H plus ion. Ammonia is a base or acid, Shillong? Ammonia is an acid or a base? What happened, Shillong? Oh, ma'am, we have studying from 3 hours. That is why, our mind is getting messed up and we have written the acid here. Ammonia is a base, okay? It's not an acid. I have given this equation for the base. See, this is the base. This is accepting. This is another definition. I think you people don't know the definition for this one. I will be telling you that. If this is the base and this is taking the H plus. See, earlier acids used to give the H plus ion. Acids are the proton donors. They are the H plus ion donors. Okay. Bases are those, like one definition for the base, like those who give OH negative. NaOH, KOH, these are the bases, okay? But there is one more definition, Shillong. The base are those which used to accept the H plus, okay? So here ammonia is accepting the H plus ion, so that is a base. And what is forming here? This is now a conjugate acid, okay? Just make sure that you are not getting confused. I will be writing the definition also. If I need to write the acid and base, the one thing we know that the compounds which gives H plus. See, if I want to write the examples HCl, H2SO4, HNO3, HI, HF, so many are there. And here if I want to write one definition for the base, what can I write along here? Those gives the OH negative. We are studying from, so long we are studying this thing. Those who give the OH negative. So what will be the examples here? NaOH, KOH, CaOH whole twice, or zinc hydroxide, anything, anything. Those who give the hydroxide are the bases. I hope this is clear till far. Now there is one more definition, Shillong. Again the same thing. Those who give the H plus ion in the solvent. Okay, this is same for these one. So same, same examples will be there. HCl, H2SO4, HNO3. Same examples are there. But here one more definition which is known as this is in the acids were giving the H plus ion, those who takes the H plus, or those who, accept the H plus. Now the very common example is the ammonia, NH3. It will take the H plus. Or, you can take the example of amines. RNH2. So many examples are there, okay? So you can just keep this thing in mind. And one more type of definition are there. Only 3 definitions are possible in the acids and the base. But I am not explaining it. I am giving you this as the homework. You people will find out. There is a term which is known as Lewis acid. And there is a term which is known as a Lewis base. Very, very important. Now this is your homework. You people will find out what are the Lewis acid, what are the Lewis base with the examples, okay? And that we will now discuss in the next class. Write it down. Is it clear, Shillong? Okay, just tell me how many of you already have the idea of Lewis acid and Lewis base. Raise your hands. Don't worry, I will not discuss right now. I know that 6 is there in the clock. How many of you have the idea of the Lewis acid and Lewis base? Raise your hands. Do you know? Okay, yes, you people know. That is good, nice. Okay, no problem. We will going to discuss that thing in the next class. Okay, so see, today we have studied a lot of things. Okay, and I hope you people understood the lecture very well. Still, if there will be any kind of doubt, you people can ask me in the next class also. And this is the very important thing, and this is not only for the chemistry, obviously, that like we have devoted the 3 hours here. You people have studied all of the concepts here. Some of you will be knowing it earlier, but many of the concepts will be new to you. Okay, so I am just saying that a proper revision is very important. Just make sure that you people will be revising all of the topics which we have studied today. The resonating structure, you have to draw the resonating structure again, because only then you will be comfortable when the next time we will be using these things, okay? So revision is very important, and just make the habit from the very first class, because today we have the very first class, and obviously we will be studying first the organic, and then we will start with the other chapters also, okay? So I'm saying that if you keep on revising, if at least, I generally told the students that at least spend 10 to 15 minutes daily with your chemistry notebook, okay? The revision is very important. So now what is required from your side is that you will be revising the topics before coming to the next class. You people will, keep all of the things in your mind, and the practice of the questions, okay? Right now we have the 1 class, but as we go ahead, there will be a WhatsApp group where you people will be there. And then the teachers used to post the assignments there, okay? So I will be giving you the questions there, so you can practice the questions and the previous year questions also from that assignment, okay? And then we will discuss them. If you want, we can discuss them on the WhatsApp group, or we can discuss in the class also, okay? So now what is the call from your side is the revision plus the practice of the similar questions, okay? So that is it from my side. If you have any queries along? Or we are just, setting and we are packing our bags and we want to go? Okay, that is fine. If you still have any kind of doubt or any query, so you can just tell me either right now, or you can just tell me in the next class, okay? So that is it for the today's class. Thank you so much. See you in the next class. Bye-bye.